Hey everyone, welcome to episode 13 of our Neet Chemistry series for 2025 and 2026. I'm your mentor, Sir Chongtham David, and with just 19 days left for Neet, it is time to shift gears. Today's focus is on chemical kinetics, a topic that not only scores big but also trains your brain to think like a chemist. We'll break down red laws, order of reactions, and integrated equations while solving 45 must practice questions that sharpen both speed and accuracy. Here's a thought to keep you going. Success, like a reaction, depends on the right conditions and the right rate of effort. So stay consistent, keep pushing, and the results will take care of themselves. Let's make every second count and race toward the finish line with focus and confidence. Now, without any further ado, I'm going to start sharing the screen. Okay, let us read the first question. Question number one. The decomposition of a substance follows the first order kinetics. Its concentration is reduced to 1 by 8 of its initial value in 24 minutes. The rate constant of the decomposition process is. So you're given option 1 by 24 per minute, B, 0.692 by 24 per minute. In this third option, 2.303 divided by 24 logarithm 1 by 8 per minute. And D, you have 22.303 by 24 log 8 by 1 minute inverse. So since this particular reaction follows a first order kinetics, let us recall what we have learned in the theory about the rate constant for first order kinetics is given by the integrated equation which we have derived and got 2.303 divided by time log of initial concentration by final concentration. Now you're given 24 minutes as a time. So 2.303 divided by 24, and the concentration is reduced by 1 by 8 times. So if you simplify this equation, you get 2.303 by 24 log of 8. So if you check the answer, the option would be D. So question number 1, option D would be the correct answer. I hope it is clear. Let's read question number 2. Consider the reaction twice A plus B gives products. When the concentration of B alone was doubled, the half-life did not change. When the concentration of A alone was doubled, the rate increases by 2 times. Now the unit of rate constant for this reaction should be. Since doubling the concentration of B does not change the half-life, the reaction is of the first order with respect to B. So order of the reaction with respect to A equals to 1 because the rate of the reaction doubles when the concentration of A is doubled, keeping the concentration of B constant. So what can we conclude? Therefore, order of the reaction is equals to 1 plus 1, that is 2, and the unit of second order reactions are liter mole inverse second inverse. So from this you can easily decode the answer, option B. This is the answer. So while analyzing this question for your side knowledge, I would give you the general formula to find the unit of rate constant. Say if it is for n order, always remember this formula. Simply substitute the value of n. If it is second order, you put n equals to 2, and there ultimately you will get the answer liter mole inverse per second. Great. Let's read question number 3. A reaction involving two different reactants can never be. So the molecularity of a reaction is the number of reactant molecules taking part in a single step of the reaction. So the reaction involving two different reactants can never be a unimolecular. So option D would be the answer, unimolecular reaction. Question number 4. Okay, it is a table and it is incomplete. Let's see anyway. Select the rate law that corresponds to the data for the following reaction. A and B react to give C. So in the first experiment, this concentration of A is 0.012 and this concentration of B is given as 0.0035 and rate of the initial rate would be 0.10. Keep in mind this is the first experiment. For the subsequent experiment, I'm going to show up the next slide. Okay, in the second experiment, you have the concentration of A, B, and this is the initial rate. So from this, you have to find the correct probable answer from this given data. So let us start calculation. I'm going to change the color of this marker. Okay, let's use it blue. Now, let the rate law be considered as, let us say, let rate equals to constant a to the power x, b to the power y. So let us divide these equations. Initially, what we have was, let us write the concentration of A and B and the initial for the first experiment as well, so as to make things simple. So in A, you have 0.024 since it was on the other side of the screen, so I'm not able to express. So I'm writing here again the concentration of B as 0.035. I hope it is visible. Okay, and if we have this, we can start calculation. All right, let us move on to the numerical part. Let us solve this question. Question number 4. Now, let us call this equation number 1, 2, 3, and 4, right? So if I divide this equation, let's divide so as to get the concentration of x and y. Divide this equation number 3 by equation number 1. What would you get here? Rate, initial rate is with respect to equation number 3. Observe carefully here, 0.10, right? So for the initial rate for the first order, the first experiment, it is same, 0.10, 0.10. And what about the concentration? This K and K gets cancelled. What is the concentration of A? Given 0.024 X. What about B? 0.035. This should be Y. Divide by the equation number 1. So you have 0.012, right? We're dividing equation number 3 by 1. This is raised to the power x and 0.035 y. So everything gets cancelled. What is left here is 1. And if I cancel this 0.12, 24, it is 2 times, so 2 to the power x. I can write here anything raised to the power 0 is 1, so it must be 2 to the power 0. I hope you're getting this. So compare these coefficients, the exponent, you get x equals to 0. Now after this, proceed in the same way to find the value of y. So how can we do this? Let us manipulate again. Divide equation number 2 by equation number 3. The objective is to find the value of x and y from the given data. First, we have divided 3 by 1 so as to find x. And the second step, we're dividing equation number 2 by 3. Always bear in mind the one which have the same concentration can be cancelled. So you have to proceed strategically. Okay. Our mission is to find y now. Now this x and x gets cancelled, so we can easily determine the value of y from this given data, right? And you know this 35 is multiple, 70 is a multiple of 35, and this y can be easily calculated. So 80 by 10 is 8. I can write here 8, and this gets cancelled. So 70 It should be 2 to the power y. And what is 8? It is 2 to the power 3. So what is the value of y now? Y is equals to 3. So to build up the red law, let me use different color. Okay, I shall use orange. Now, for this red law, you have to substitute whatever you have got as x and whatever you have got as y. Y is 3, x is 0, right? So the red equation will be red equals to, red law will be k. What is the value of x? 0. What is the value of b? It should be b3. So this is eliminated. Now you have only red constant and b cube. So the answer would be option A. Okay, I hope it is understood. It's clear, right? Let's see question number 5. Consider the reaction nitrogen and hydrogen gives ammonia. The equality relationship between ammonia and hydrogen rate is. So if we write the rate of the reaction in terms of concentration of ammonia and hydrogen only, then the rate can be written as, or you can say rate of the reaction R equals to, with respect to the stoichiometric coefficients, you compare, do the comparison, and you can easily determine the rate with respect to ammonia. See, what is the significance of this negative sign? It indicates it is consumption. Okay, so do the comparison properly. D ammonia by time. See, when D is given in small letter, it is called differential rate law. When it is given in delta, it is called average rate law. So do the comparison. The answer would be option A. I hope it is clear. Moving on to question number 6. Disonium salt decomposes as follows. Benzene, disonium chloride is chlorobenzene. At 0 degrees Celsius, the evolution of nitrogen becomes 2 times faster when the initial concentration of the salt is doubled. Therefore, it is. So as this doubling takes place, the initial concentration doubles the rate of the reaction. So order would be a first order reaction. Option A is the answer to question number 6. Moving on to the next question, number 7. This is chloroform undergoing chlorination. Red law is given. It should be half, okay? On the basis of the information provided, which of the following option will be correct? So rate law for any chemical reaction can be predicted accurately by looking at the balance equation. The rate law for a chemical reaction has to be determined experimentally, either determined experimentally or obtained from balanced chemical equation. Rate law will be same, and none of the above is correct. You see, rate law has to be determined experimentally as chlorine is raised to the power half. So in the rate law, whereas its stoichiometric coefficient in the balanced chemical equation is 1. So B would be the answer for question number 7. I hope it is clear. Question number 8. Which of the following statement is incorrect? Now, in Neet exam, you're made to get confusion, right? So always be alert. Don't forget to read the question thoroughly. Some students thought you have to check this, you have to find the correct answer, and so they're hunting for the correct answer. No, this is not the case, right? Question is asking find the incorrect answer. That incorrect statement will be the correct option. Are you getting the point? Okay, so be very careful with this. Now answer the question, which is the incorrect statement. Okay, as far as I can see, from the statement, activation energy for the forward reaction equals that of the reverse reaction. This particular question was uh, asked by a student recently. She was asking, is this the correct answer? No, this is the incorrect statement, right? So A will be the answer to question number 8. Activation of energy cannot be equal to the activation of the reverse reaction. They will be totally different because you're going to climb the uphill. Okay, if it is for exothermic reaction, the process keeps on decreasing. The graph looks very curved as we go in the forward direction. So eventually the activation energy will be very high for the reverse reaction, although it is very less for the forward reaction. I hope it's logically clear, right? So for reversible reaction, increase in temperature increases the rate of the forward. Okay, this is the correct answer. The larger the initial reactant concentration, the shorter is the half-life. So option A will be the incorrect statement. Let us read question number 9. In a reaction, A changing to product, when start is made from the concentration 8 into 10 to the power minus 2 of A, half-life is found to be 120 minutes. And for the initial concentration, okay, 4 into 10 to the power minus 2 molar, half-life of the reaction becomes 240. So the order of the reaction is, question is asking. So half-life method you have to bear in mind. Keep this point in mind. Half-life is, okay, let me take the ratio. The half-life A1, A2. And since you have taken the ratio, you have to raise this as n minus 1. Now you equate this 120 divided by 240 because it's given in the question, right? 120 minutes, and here you have 240 minutes. So you have 4 into 10 to the power minus 2 with respect to 8 into 10 to the power minus 2. And what is the value of n minus 1? It's not given. You are asked to find the order. So you can cancel this 1 by 2. Okay. 1 by 2. You can also cancel this 1 by 2. 10, 10 gets cancelled. 1 by 2, 1 by 2. They're all the same. Now, what would be the answer for this? It would be n minus 1 equals to 1. So n equals to 2. It is a second order reaction. The correct answer for this question would be option number C. It's clear, right? Let's read question number 10. During decomposition of an activated complex, okay, which is the following, which is the correct answer for this question number 10? So let's see. Energy is always released. Good. This is correct. It is always absorbed. Wrong. Energy does not change. This is wrong. Reactants may be formed. If 1 and 4 is correct, B is the answer to question number 10. Good. Let's read question number 11. Which of the following statement is incorrect? So read the statement. Energy is always released when complex decompose. This is correct. Peak of the energy distribution curve corresponds to the most probable potential energy. Okay, this is given by Boltzmann distribution, fraction of the molecules that is taking part, right? So option B is the correct answer for this question. Others are not correct. Okay, let's read question number 12. A catalyst increases rate of the reaction by decreasing the activation energy. Question number 13. Consider a reaction A and B giving, no, G and H giving product when the concentration of both reactants are double, the rate increases 8 times. Okay, it's interesting. Keep this point in mind. This will be held handy to calculate the question. But when concentration of G is doubled, see, G is doubled. When G is doubled, keeping the concentration of H fixed, the rate is doubled. So what is the overall order of the reaction? See, overall order is the sum of orders with respect to its reactants present in the rate law. So now let us see, let us consider order be X for G and Y with respect to H. Now to calculate this question, we have, let us make up a table, experiment, concentration of G, concentration of H, and let us write here rate. In the first experiment, you have A and you have B, and this was rate as given according to the question. Now, by the question, the conditions are the concentration of G is doubled. Both the reactants are doubled. So we will write here twice B, and it says it increases how many times? 8 times. Okay. In the third case, twice A, and this is B. And this increases how many times? It increases 2 times. Double means 2 times. Twice R. So for this experiment number 1 and 3, the rate is doubled. Okay. For this experiment number 1 and 3, the rate is doubled when concentration of this G is doubled. Right. So, okay, let us write here. since for equation number 1 and equation number 3, the rate is doubled only when this concentration of G is doubled. But keeping that of H constant. This is the condition. So what can we say from this? Rate is going to be prof G. That means x equals to 1. From equation number 2 and 3, we can say from equation number 2 and 3, look here, from equation number 2 and 3, we can say that the value of y equals to 2. So what is overall order? It will be a third order reaction, right? I hope it is understood. Question number 14, a first order reaction product, it gives product. The concentration of A changes from zero point 0.1 to 0.025 molar in 40 minutes. The rate of the reaction when the concentration of A is zero point 0.01 molar is. Okay, use the first order rate equation. K equals to, the integrated equation is 2.303 by time, log of initial by final. This you all know, right? So substitute the value 2.303 by 40. Given time is in 40 minutes. Log of initial concentration 0.1, final concentration is 0.025. Now let us substitute these values. You have 2.303 by 40. Okay, you can cancel this by 4. So you have log 4. Simplify this. What is log 4? It is 0.602 divided by 40. Now, after calculation, you will be getting approximately 3 10 to the power minus 2. So far you have the value of rate constant. I hope it is understood. Now, let us find the rate. Since this is a first order reaction, rate equals to rate constant into concentration of A. What you have just found out was 3 into 10 to the power minus 2. And then this is the rate constant multiplied with the concentration of A. Okay. So you have approximately 3 into 10 to the power minus 4 value. Okay. So this is the answer. Question number 14. It will be approximately 3.4 into 10 to the power minus 4. This is the answer to question number 14. I hope it is clear. Let us read question number 15. The given reaction is an example of, so 2 plus 1, third order reaction C. In the first order reaction, A gives B. If K is the rate constant and initial concentration of the reactant A is 0.5, then the half-life is. Okay, so for first order reaction, okay, what can we conclude from this practice question is that for Neet exam, chemical kinetics, important topic is from the first order. So many questions are going to be asked, and the important point you have to remember is first order reaction is frequently asked in the exam. So be prepared for this. Question can come from first order reaction. Log initial by final concentration. So this you know when time is half-life, let us say T half is a half-life, what would be the value of K? K would be written as 2.303 divided by half-life and log of A, the concentration would be reduced by half, right? This is the general way we have done in the theory part. So 2.303 divided by K if we are supposed to find the half-life. So after simplification, log 2, and what is this value? It is nothing but ln2 by K. Okay, this is induction. Anyway, T half is ln2 by K. Question number 16. Option C would be the answer for question number 16. I hope it is understood. Let's move on to question number 17. The integrated rate equation can be determined for, can be done both by zero order and first order reaction. This is a simple question. Let's move on to question number 18. The rate constant, the activation energy, and Arrhenius constant. Okay, three terms are given here: rate constant, activation energy, and this Arrhenius parameters are given. What is the value of rate constant as time this temperature tends to infinity? Okay, so what is Arrhenius equation that you have to know? Remember, it is given by log. It is turned into something else. Let me erase all this. I have used a magic. Let me erase. It's quite funny. Okay. Question number 18, right? So let's use Arrhenius equation log K2 by K1 equals to activation energy divided by 2.303 R 1 by T2 minus, sorry, 1 by T1 minus 1 by. Okay, use this equation and you will be getting the answer very soon. Okay, now let us substitute the values. K2, what is the given value of K1? 3.1 into 10 to the power minus 4. And activation energy, you have to convert this to joule from kilojoule. You can convert 1.4. This is in kilojoule. So you write 1000. Okay, kilo means 1000. Okay, 2.30. You learn by heart the product of R in 2.303. Okay, that will save your time in the exam hall. 298 minus. So you are about to find time, right? So as this temperature tends to infinity, you have 1 by T would tend to 0. Clear? So let us continue solving this part. So what can we conclude from this? We can say this log K2 by 3 into 10 to the power minus 4 would give. So if this term is 0, what is left here? We do the simplification. Cancel with this approximately 8 1s are 8, 8 2, 8 10. Let's say 8 1 is 8, right? So 2 32. 1 4. 14 by 2 7. And 7 divided by 1 by 2 98 70. 298, right? So 18. So approximately the value would come to be approximately, let's say 18.2. Okay. Now you have to find the antilog value of this. So K2 would be equals to approximately, you have 18, 19, 198 into 10 to the power 18, again multiply with this 3 into 10 to the power minus 4. The answer would be approximately 6313 point. Okay, answer would be approximately 6 into 10 to the power. Approximate value 6 into 10 to the power 14 second inverse. So B is the answer to question number 18. I hope it is clear, right? Let's say question number 19. According to the adsorption theory of catalysis, the speed of the reaction increases because adsorption lowers the activation energy. So 19 would be C. I hope it is clear. Question number 20. Consider this general chemical changes from A and B to product. The rate of the reaction with respect to A is R1, with respect to B is R2, and this relation between R1 and R2. So this is the question. So now let's write the reaction. Twice A plus thrice B is giving change of product. So minus 1 by 2, if we write the rate, dA by dt minus 1 by 3 dB by dt. So I can say I can write 1 by 2 R1 equals to 1 by 3 R2. Okay. So what is the relation between these two? 3 R1 equals to 2 R2. Right. So question number 20 A is the answer for question number 20. I hope it's clear. Let's read question number 21. In a first order reaction, the concentration of reactant decreased from zero point 0.8 to zero point 0.4 in 15 minutes. The time taken for the concentration to change from zero point 0.1 to 0.025 molar is. So the half-life is 15 minutes. To fold the concentration from zero point 0.1 to 0.025, we need two half-life. So what is two half-life of 15? It would be 30 minutes. Okay. This is the answer for question number 21. Question number 22. So you have to use Arrhenius equation. Arrhenius equation would be ln K2 by, it's all messed up, but we'll just find out the answer for this, okay? Ln K2 by K1 equals activation energy. This is the general Arrhenius equation, okay? So if I remove this negative sign in front, it becomes, this will be interchanged, T2 and T1. Now, the final Arrhenius equation would be K1 by K2 would be equals to minus A by R 1 by T1 minus 1 by T2. This can also be written in this way. Anyway, let's read question number 23. Since these options are not clear, we'll move to question number 23. The 1 by 4th life can be taken as a time for the concentration of a reactant to drop from 3 by 4th of its initial value. If the rate constant for the first order reaction is K, the 1 by 4, the quarter life can be written as. So how would you write this equation? From the first order reaction, you have 1 by 4 can be written as 2.303 divided by K log of initial by, so if I subtract 1 minus 1 by 4, it will be 3 by 4. Okay. So 2.303 by K, it will give rise to log 4 by 3. Okay. So 2.303 by K, this would be log 4 minus log 3. What is log 4? It is 0.602, right? So multiply this and 602 and this log 3 is 0.477. The value after multiplying would be approximately 29 by K. 23, option number C. Option C would be the answer for question number 23. I hope it is clear. Let's read question number 24. The decomposition of ammonia in tungsten surface at 500 Kelvin follows a zero order kinetics. The half-life of this reaction is 45. When the initial pressure is 4 bar, the half-life period of the reaction when the initial pressure is 16 bar at the same temperature. So for for a zero order reaction, the half-life is directly proportional to initial concentration or initial pressure. So what you can write here is this half-life, let's say half-life 1 is directly proportional to P1 and half-life 2 is again directly proportional to P2. You find the ratio for this P1 and P2. It would be equals to P2 by P1. Okay, so considering this half-life 1 divided by this pressure, it would be 45. Okay, time of half-life is 45 given here. It equals to pressure 16 by 4. So the half-life would be 16 by 4 is 4, right? 4 into 45 equals to 180 minute. Option D is the answer for question number 24. Moving on to question number 25. In a first order reaction, reactant concentration C varies with time Ts. So if you can recall, the graph would look something like this, right? According to the slope intercept equation, y equals to mx plus c. So this is the slope. The slope is a negative slope because this angle is in the direction of the negative axis of x-axis. So what is the answer for this question? Log c is in the y-axis, right? So in the first order reaction, reactant concentration C varies with time t, and log C decrease linearly with t. So this must be the answer for question 25. How it's clear, let's read question number 26. For a reaction A gives B, plot of log half-life versus initial concentration is shown. If the initial concentration of A is represented by A naught, the half-life, the order of the reaction is. Okay, for this question, you should know that the plot for the given equation, it is a zero order reaction because it depends directly on the concentration of the reactants. Question number 27, let's read fast. The rate of a chemical reaction doubles every 10-degree rise of temperature, and if the temperature is raised by 50 degrees Celsius, the rate of the reaction would be. Okay, don't forget to use this formula. What is 2 to the power 5? 32 minutes. Sorry, 32 times. This is the answer for question 27. Moving on to 28, the for first order reaction, the okay, 0.75 life is 1368 seconds. Sorry. Therefore, the specific rate constant in second inverse is. So how would you account for this question? That's right. The rate constant K equals to 2.303 divided by the time is 1386. So log of initial by final minus 75. So on solving, this is 25, you have 4, right? So 4 into 2.303 divided by 1386, approximately 10 to the power minus 3. 28A would be the answer for question 28. Let's read question number 29. The integrated rate equation is given. RT equals to log C naught. This is initial and this is the reactant. So next, 29 is incomplete. Let's read question number 30. The energies of activation for forward and reverse are given. A2 plus B2 gives twice AB. These are the values of the energies of activation or activation energy in short. And the presence of catalyst lowers activation energy for both by 100. The enthalpy of the reaction in the presence of the catalyst will be. Okay. So to solve this question, what is the equation you have to follow? Enthalpy is the difference of forward activation and backward activation. So calculate. So you have a negative enthalpy, 20 kilojoule per mole. You're getting this value. Done. Okay. Simply know the formula. This type of question was already said in Neet 2021. Okay. Question 31. The half-life period of a first order reaction is 15. The amount of substance left after 1 hour will be. So given half-life is 15 minutes and time is 1 hour, which is equal to 60 minutes. So from the general rule, that is total life will be n into that particular half-life. So can you find n from this order of the reaction is, this is where you have to find, right? So 1 hour is 16 divided by given half-life 15. 4, you have this value. Now from the formula, that is n divided by n naught is half n. Okay. So you have 1 by 2. What is the value of n? It's given 4. So it would be 1 by 16 of the original amount. Option C would be the answer for question 31. Now it's clear. Question number 32, reaction rates are given. And this is the rate law. If the concentration of A is double and B is made half, what is the ratio of the new rate to the earlier rate? So from rate 1, what can we deduce? We can say rate 1 equals to rate constant, A to the power and let's say B to the power. And these are the unknown, okay? This is important question. R2 would be K, and this is increased double times, and B is made to reduce 1 by 2 times. Now what you have to do is you find the value, the ratio of these two, because the question is asking what is the ratio of the new rate to the earlier rate. New rate should be 2, earlier should be 1, and you simply substitute the value twice A into half that of B, and the respective stoichiometric coefficients are n, m divided by k, a to the power n, b to the power m. Cancel all these terms which are common, and what is left now is 2 to the power n, and you have 1 by 2 to the power m. Okay, so can I write like this? Twice n into twice minus m. The base are same, the power should be n, right? So 2 and minus m. So this is the answer for question number 32. D is the answer. So important question. Let's move on to the next question, question number 33. Okay, this is a reaction based on photochemistry. The reaction of ozone with oxygen atoms in the presence of chlorine atoms can be occurred by a two-step process shown below. Okay, this is activated, right? Ozone and chlorine, it gives a first reaction, and the second elementary reaction is both these are activated and gives oxygen and activated chlorine. The closest rate constant for the overall reaction is. So what you have to do here is you have to add this overall rate constant. Simply add the overall rate constant, that is, what is the given value here? 5.2 and 2.6. Okay. 9 and 10, it gives 19. Add this value, you have 11, 8, 7.8. Approximately you have 7 point. So 5.2, okay, you have to multiply this. These are the two. If you add this, the equilibrium constant is multiplied, right? So stepwise stability constant, 5.2, 10 to the power 19. Okay, 9 into 2.6, 10 to the power 10. You have to add this 19, right? 2.6 and 5.2. If you multiply this, the value comes out to be approximately 1.4, 10 to the power 20. Option A is the answer for question number 33. 34. This is the question based on Arrhenius equation. And activation energy can be calculated by plotting. So you know Arrhenius equation is given by K equals to A e to the power minus EA by RT. When you take the log of this equation, you get log K equals to log A minus activation energy by 2.303 R 1 by T. Compare this with the slope intercept log K versus 1 by T. This is Y and this is X and this is M, and sorry, this is M and this is your intercept. Y equals to mx plus c, right? So this is in the form of slope intercept form. The answer would be, no, B, not A, okay? B is the answer to question number 34. I hope it's clear. Let's read question number 35. I hope you're all keeping up with me so far. We're about to be done. Let's keep on going. Feel the energy, right? So question number 35. For the reaction system, nitric oxide plus oxygen gives nitrogen dioxide. Volume is suddenly reduced to half its value by increasing the pressure. If the reaction is of first order with respect to oxygen and second with respect to nitric oxide, the rate of the reaction will be. So rate of the reaction, you need to write it down. The rate law equals to K O2 nitric oxide. So from the rate law, you write the stoichiometric coefficient. So when the volume is reduced to half, the concentration will be doubled, right? So that is the general form, because we know concentration is mole per volume. So when the volume is reduced to half, the concentration automatically gets doubled. So what is the new rate? It can be written as K to oxygen. Then you have double. I have already explained how this is derived, right? So what is the answer? 2 to the 4, 4 to the 8. Take the 8 outside the bracket, and you can now compare, do the comparison. Nitric oxide. Okay, so this is the equation, and the rate will increase how many times? 8 times. So it increases to 8 times. B is the correct answer for question number 35. I hope it is clear. Question number 36. In the reaction of formation of sulfur trioxide by contact process, the rate of reaction was measured as the change in concentration by time, right? So how would you account for this? The sulfur dioxide by time. This is again equals to oxygen by time, let's say, because This negative symbol signifies that the concentration drops for the reacting species and increases for the product. So can I say this negative concentration by time of sulfur dioxide is minus 2 times that of the concentration change by time for oxygen. So this would be equals to minus 2 and you're given the value how much? Minus 2.5. Okay. So substitute this value, you'll be getting 2.5 10 to the power minus 4 quadrimolar, right? So 5 into 10 to the power minus 4 mole per liter per second. So question number 36, D would be the answer for question number 36. I hope it is understood. Let's read question number 37. A reactant A from the forms two products. These are the elementary reaction with activation energy 1 and 2. And if EA2 is equals to 2EA1, then K1 and K2 are related as. This is an interesting question, a very important question. You can mark it down. This is a, okay. Let us write the Arrhenius equation. This is the Arrhenius factor and exponent raised to the power activation energy, gas constant into time. Okay, this is temperature, not time. Okay, right constant A2 into this is Arrhenius factor, activation energy by gas constant and temperature 2. So when you divide this equation 1 and 2, you would be getting an equation. The exponent gets subtracted. EA2 minus is our activation energy and divide this by the product of gas constant and temperature. Let us say this is equation number 3. But what is given to you is you have two activation energy which are equal but double times. Okay. So on substituting this value to this particular equation number 3, you will be getting the rate constant K1 by K2. So K2 is transpose on the other side. So into Arrhenius constant A to the power minus EA by RT. So refer this with the option and you will get the answer. Option C is the answer for this question number 37. I hope it is clear and understood, right? Moving on to the next question, question number 38. Consider an endothermic reaction X changed to Y with activation energy B and F for the forward and backward and forward respectively. And in general, what is the correct answer for this question? You see, enthalpy is, I have already explained this before. Go through and read it again in case you have missed it. Backward. Okay, I should write here backward. So for me, okay, forward activation energy minus backward would be the enthalpy. So for endothermic process, enthalpy change, heat content of the system is positive. Hence, for delta H to be positive, you have to have activation energy B should be less than forward. So consider this and find the option. C is the most probable answer to question number 38. Okay, moving on to question number 39. Which of the following influences the rate of the reaction form in a solution? So all of the above will influence temperature, activation, energy, presence of catalyst. Question number 39 done. 40. The rate of the reaction quadruple means increases 4 times when the temperature change from 300 to 310. The activation energy of this reaction is. Okay. Ln, what is the Arrhenius equation? K1 by K2 equals to activation energy by gas constant 1 by T1 minus T2. Can I write here log 4 equals to activation energy by what is gas constant 8.314. Okay, given temperature are 310 and 300, right? From this, multiply 300 and 310, and you would be easily be getting the value of activation energy. Anyway, let's calculate. So ln 4 can be written as ln 2 to the power 2. That 2 is raised in the power, so it comes in the coefficient because this is by using the property of log. You have activation energy divided by 8.314 and 310 minus 300, 310 into 300. Now solve activation energy. So what you have here, Find the value of log 2. 0.301 into 2 will be 0.606, let us say. Then 2 multiplied with 8.314. This temperature multiplication from the LCM. We'll write it here, 300 into 310. And what you have in the numerator comes in the denominator. After subtracting 310 and 300, you get 10. Okay, cancel this. 6 to the 12, 1.2 into 8, approximately 8.4, and then 314 into 300. You have to multiply, take the decimal approximately. In terms of kilojoule, this must be 107.2. So this will be option A. Option A is the correct answer for question number 46. Okay, consider the reaction chlorine and hydrogen sulfide changes to sulfur, hydrogen ion, and chloride. The rate equation for this is very simple question. It's given as rate equals to K chlorine. Which of the following mechanism are consistent with the given rate equation? So how to answer this question? So you have to find that the RDS or rate determining step is the slowest step. So if you consider this first option A, we find rate equals to chlorine. I can write it here, rate equals to the slowest step is the rate determining step. So chlorine and hydrogen sulfide. Now if you consider option B, the slowest step, the rate would be written as K, chlorine and bisulfide. And if you, for this equation, B, right? So we have this equation, hydrogen sulfide changing to hydrogen ion and HS minus. So equilibrium constant can be rewritten as for this equation B, equilibrium constant equals to H plus H minus H2S. So if you find HS minus, multiply this. So you will be getting the answer. Okay, only this B only is the correct answer for question number 41. Moving on to the next question, question number 42. Arrhenius equation is, okay, the Arrhenius plot is equal to 42. This is easy. It will be A. Okay, question number 43. A schematic plot of log equilibrium constant versus inverse of temperature for a reaction is shown. So this graph shows that the reaction is going to be exothermic. Right, so log K equals to minus delta H by RT. That was the equation. So for this exothermic reaction, enthalpy change is less than 0. So log K versus 1 by temperature would be negative straight line with a positive slope. So this is option D. This is exothermic reaction. Okay, question number 44. The plot variation of the rate constant with temperature given. It follows Arrhenius equation is the one which follows Arrhenius equation. That is K goes to Arrhenius factor into e to the power minus activation energy by RT. The rate constant for that increases exponentially with temperature, right? So A is the answer for question number 44. Okay, as usual, you solve question number 45 and try to give the answer in the comment section. And thank you for joining up to the end. I wish you all the best. Happy learning.